Okay, now that we have worked out examples and we understand a little bit of exponential growth, we can use all we learned to solve some basic problems. So in this example, say a city has population of 550,000 people and is growing by 2% each year. What is the population of the city in 10 years? So according to what we talked about in the previous video, if you're coming from there, my formula or my equation or my function that models the situation would be P sub n, or Pn. If you use two function notation, it's fine, right? Equals initial value times 1 plus r to the n. So this is what we're talking for exponential growth. So my initial value is 550,000. So if I write 550, that's fine. You have to remember that the units are in thousands. And then I put 1 plus, as a percent, as a decimal, this is 0.2 to the n. So this is my function or my notation. If you use this notation or this notation, it doesn't matter. And n is the number of years, so all I have to do is use 10 in there. So I'm trying to find what is this P10. So it'd be 550 times, I could put this in one number, of course, it's 1.02 to the power of 10. So you need a calculator for this. I use the Desmo Scientific Calculator. And I can write 550, parentheses, I can type it exactly as it is, 1.02, close the parentheses, then use this, the second button in this row, then when it says a to the b, to get an exponent and then type a 10 up there. So I get 670.44. I'm going to round to 2 decimals, so that becomes a 45. And these are thousands of people, so your answer should be 670,000 people in 10 years. Okay. So my second example is similar. It says in a city in the year 2010 had a population of 1.2 million. In the year 2015, the population was 1.35 million. Assuming exponential growth, find the expected population of this city this year in 2020. So this problem is a little bit different. It's still going to be an exponential growth, so I need to find Pn is going to be my P sub 0 times 1 plus r to the n. A question here is that I don't know who is the r, right? What is given to me are two values. I know that in a certain year, in 2010, I had 1.2 million, and a different year, in 2015, it was 1.35 million. So I'm going to use this one as my initial value. It's totally arbitrary, right? This is going to be my year 0. So I'm going to have like n and Pn. I have two values. I know that in the year 0, that's going to correspond to 2010, I had 1.2. So that tells me something, right? I do know who is this number. So I do know that my Pn is going to have the form 1.2. If I agree that I'm going to use that as my year 0, 1 plus, and what I don't know is the r, right? But I was given another year. I'm giving that in the year 2015, the population was 1.35. So I do know that 5 years from then, right, 2015 compared to 2010, it was in year 5, I had 1.35. So I can use this information. I'm going to use this as my 5. I'm going to use that as my n. I'm going to have the P, this will be P5 on that side. And I'm going to get an equation that all I need that I can use to solve r. Because I would have everything else except the r. So that's how we solve this problem. So I'm going to use the one I know, we know that P5 is 1.35. Or another way to say it, that P is 1.35 when n is 5. So we can use that 1.35 is going to be 1.2 times 1 plus r to the 5, right? I'm using this for my 5 and this for my p5. So this is an equation that I should be able to solve for r, have everything else except r. And once I find my r, then I can go back and fill what this function or this model looks like. So that's all for r. So I'm going to give me some space here. This over here. Okay, so what I need to do is I'm going to put a little line here. I'm going to write this equation backwards. Usually we want to have my variable on the left side, right? It totally doesn't matter. So the first step I'm going to do is dividing by 1.2. So I'm going to have 1.35 divided by 1.2. I'm getting this equation and dividing in this equation, and I'm dividing by the factor 1.2. So showing up division on the other side. And now the 1 plus r is inside this parentheses with a fifth power. So I have to be careful how to manipulate this. I basically, what I do is I'm going to do the steps by step here. Copy that. I'm going to paste it. And what I do is take the fifth root on both sides, right? I have the fifth power, so I take the fifth root. So on the left side, that just disappears the power, and I have 1 plus r. On the right side, I have that fifth root of the quantity 1.35 divided by 1.2. I'm leaving that as that on purpose, and I'm going to do one operation with the calculator at the very end. So the last thing I need to do, of course, is subtract a 1, and I know what r is. So my last step is going to be that r is the fifth root of 1.35 divided by 1.2. Answer of that in minus 1, correct? Because this is 1. I'm going to be subtracting that 1 from both sides. Okay, so in the calculator, finally, let's go to Desmos. And I can type, I'll type the fifth root. So if you see the second entry in this row is the nth root, so you can use that. Right, and it has my cursor is up there in the bottom to put this the fifth root. Now you can put in inside the root, the radical. I can type the 1.35 divided by 1.2. I used the division button, and it made this fraction. And then be careful now. I need to scroll to the right. So at the end of this row, at the very end of that same row on the extreme right, there's these arrows to navigate. So you have to be careful. If I type it in there, I'm still inside the root, so I don't want that. I want to navigate one more with the arrow up, outside, sorry, and now I'm outside of the root, minus 1. Okay, so my answer is 0.02338. I'm going to leave it like that. So that's my r. So the rate, or the exponential growth rate is 2.38%. Now we haven't solved the question yet. The question was, assuming exponential growth, find the expected population in this year, in 2020. So I know my formula. Now I know my formula, or my function would be Pn is 1.2 times 1 plus 0.0238. Of course, I can write that in like 10238 to the power of n. And they're asking us to find it in the year 2020. My year 0 was 2010. That's what I used. So that means that I need to find this when the n is 10. So my final answer is going to be, what is it when p10? So I can do, this would be 1.2 times 1.0238 to the 10. And again, let's go to our calculator. So it's 1.2 times 1.0238 to the power of 10. So it's 1.518. These are millions of people, so 1.518 million in the year 2020. Have time for one last example. So my next example is going to be this one. So the population of squirrels in an island was 1,200 in the year 2005, and is growing by 2.3% each year. In what year should we expect the population of squirrels to reach 2,500? So again, we're using this situation, P0, 1 plus R to the N. My P0 is the 1,200. I'm using this one like my year 0. And I know everything. It's 1 plus, this is my R, so 0.023 to the N. But the question is a little bit backwards. Let me put it together just like this. Sorry. So this is what I have. Pn equals this. But my question now is asking for something different. It's saying how many years I need to wait for the population to be 2,500. So I'm going to want to solve for n. For what value of n is Pn 2,500, right? So this is a different question. Now we need to solve for n. In this equation, we're going to write, I want 2,500 on this side, my population of squirrels, and I don't know what is the n value over here. So now the variable that I'm trying to solve for is in the exponent. But thankfully, if you follow these videos, we know how to solve for exponents now using logarithms. So the first thing I need to do is divide by 1,200. So I'm going to have 2,500 divided by 1,200 equals 1.023 to the power of n. And then here is what we do. I'm going to write the log of both sides. I'm going to cancel a couple of zeros here. Hope it doesn't, right? If I have hundreds and hundreds, I can simplify a little bit. Doesn't matter if you don't do it. On this side, I'm going to write the log. So I'm applying the log base 10, right? If I don't write the base, it means to the base like that. But the magic of doing the logs here, remember, is that we have this property that allows me to bring this in here. That's the magic of logs. So I'm not going to write this step. So that's a step, taking the logs. And the next step would be put this guy, putting the n in front. So I think I should write it instead of skipping it, because that's the important step to write. I need some space, so let me make all this smaller. Put it over here. So I have this equation, and I'm going to copy it. Put it here with the n. Oh, sorry, but then here, originally the n is up here. In my next step, I bring it down. Okay, and we solve for it, because now all I need to do is now this number, once I punch it in my calculator, it's a decimal, right? No, I don't want to type it right now, because I don't want to copy the decimals and round and miss information. I'm going to keep it like that. But the important thing is that now what I'm going to do is divide by this quantity, and it's going to be over here. And that's going to solve for the n, right? So again, I'm going to leave this step here, but that's what I'm going to do in my next step. So my next step, I copy what I had. Since I'm dividing by this term, it goes to the denominator over here. So it looks like a very big fraction, but that's all it is. Let me put it like this, right? That's my value then. That's all I have to do. So let me put that in my calculator. Let's put this a little bit smaller. Okay, so let's grab our calculator, and I have to be careful to type this carefully. But that's not a problem. These calculators can handle it. I'm going to type the log button. So to find the log button, you have to go here to the function. In this row, the function, there's a third entry, right? And you see the log becomes, it shows up down here in this row. So type, sorry about that, and type the log. And then I'm going to put, I have the log of 25, so I have to go back. My number screen disappeared, so my keyboard, so press back to main, and you get the keyboard back. So 25 divided by 12, and then again you have to scroll with the arrows outside of the denominator, close the parentheses. Now I'm dividing by, I need a log again. So I go to functions and press the log button of 1.023. So I need the keyboard again, the numerical keyboard to press main 1.0, oops, 1.023. So 32.27. These were a number of years. 28 if I round. So this was number of years since 2005. So it's the year 2037, right? Uh, 2037. That'll be my final answer. Okay.